Go.
So these are practice problems for uniformly accelerated motion, and the equations for uniformly accelerated motion, or at least some of them, are up here. So D is displacement. It can also be represented by triangle X or a change in distance. VI is initial velocity. It can also be represented by V sub O or U. VF is final velocity. It can also be notated by just V. And then T is time. Also acceleration is A over here. So these are the equations, and they're going to be used in these two practice problems down here. So the first practice problem is a race car accelerates uniformly from 18.5 meters per second to 46.1 meters per second in 2.4 seconds. Find acceleration and distance traveled. So I've just written what our variables are over here, or our known variables. So the initial velocity is going to be this 18.5 meters per second. And then the final velocity is going to be the 46.1 meters per second. And then time is going to be 2.4 seconds. 2.47 seconds. Okay, and so I'm going to be using one of my equations up here, since I have to find both the acceleration and the distance traveled. I'm going to first find acceleration, which is the equation A equals change in velocity over time. So A equals final velocity minus initial velocity over time. So A equals, I'm taking all the values from here, A equals 46.1 minus 18.5 over 2.47. And that's going to equal 11.2 meters per second squared. And the reason I did acceleration first is because I need it for my displacement problem as a variable in my displacement problem down here. So I need to find this before I can complete this equation. So to find displacement, I'm doing initial velocity times time plus 1/2 acceleration times time squared. So displacement equals initial velocity, 18.5, times time, 2.47 seconds, plus 1/2 acceleration, so 11.2, and then times time squared. And that is going to yield 79.8 meters. So that's that problem done.